Since the James Webb Space Telescope landed in space, it has transmitted the most stunning photographs of the universe to us, viewers. Although they come as a massive surprise to most cosmologists and professional astronomers because they defy theory in every way, a deluge of technical astronomical publications have been released online. At the same time, some debates and arguments have surfaced. The scientists repeatedly note that the photos reveal a considerable number of surprises. Ironically, some are conflicting and shocking. One notable but shocking one is how the James Webb theory proves that the Big Bang theory never happened. Is this correct? Why do cosmologists get alarmed by the JWST images if it isn't? The Big Bang idea states that the universe began 14 billion years ago in an enormously hot, dense state and continues to expand. There has been unhappiness with the standard model, which starts with the Big Bang since it was initially put out by Georges Lemaitre almost a century ago. Despite this, most cosmological theorists have supported that concept for decades as undeniable truth. The Big Bang nucleosynthesis epoch generated chiefly 75% hydrogen and 25% helium and a small amount of lithium. The cosmos then cooled down enough to make atoms after 300,000 years, and gravitational pull slowly but surely formed stars. The first ones were large enough to explode. The shockwaves sent out hydrogen gas, leading to pockets that started star formation in earnest. However, it still takes 500 million years for a galaxy to accumulate enough stars. The further a galaxy is from us, the sooner it develops. The farther back in time it is, the quicker it evaporates from our view. The redshift of the light results from this movement. This link is so strong that astronomers use redshift for time. The James Webb Space Telescope excels in the infrared, which the Hubble Space Telescope could not detect because those early galaxies were so redshifted and could only be seen there. Thus, one of the objectives of the JWST was to see the first galaxies, and they are definitely observing many of them. Webb's photos are surprisingly smooth, tiny, and shockingly ancient, contrary to expectations that they would only validate the standard model of the cosmos. The JWST's photos are obviously and constantly refuting this theory. Therefore, the new evidence makes them panic. The Big Bang is partially a metaphysical question. Disagreements over it will inescapably last long. In a recent piece, a science writer and independent researcher, Eric J. Lerner, made a particularly questionable assertion. In the essay, Lerner said that the Big Bang did not occur, and guess what? His argument is based on the JWST data. Although we can't say the same of his book, The Big Bang Theory Never Happened, which he published in 1991, long before the JWST was developed. Many individuals on the internet were left perplexed by it. According to Lerner, the cosmos is immobile and eternal, which begs for the involvement of a supernatural creator. This was a concept that was different when he released his book. Based on their own models, eminent scientists also suggest that the cosmos was static in the 1950s and 1960s. Lerner recently wrote an essay on the JWST and said that the galaxies it had viewed were too smooth, too ancient, and too little to support the Big Bang. He said there were too many disk galaxies in the cosmos 400 million years ago. Physicists quickly responded to Lerner's assertions in The Big Bang Never Happened. In several publications, astrophysicist and Big Bang proponent Edward L. Wright disputed Lerner's theory on several grounds. Sean Carroll, a physicist and science communicator, referred to Lerner as a crackpot in reaction to an article from 2004. Lerner has persisted in publishing his opinions despite the criticism and scorn. His articles still include a string of contradictions. But since Lerner's arguments focus on galaxy formation theory rather than the Big Bang hypotheses, several physicists have criticized his unqualified extrapolation as opportunistic. Hans Alfvén, whose groundbreaking work in magnetohydrodynamics earned him the 1970 Nobel Prize in Physics, envisioned a cosmos in which the universe expansion may be explained by anything other than the Big Bang. The steady-state theory was also developed by Fred Hoyle, an astronomer best known for describing how fusion events in stars produce chemical elements. At the time, it was the only viable alternative to the Big Bang idea. The cosmic microwave background, a sea of microwave radiation permeating the cosmos, is crucial. It is thought by physicists to be radiation left behind from when our universe was just 380,000 years old. The Cosmic Background Explorer, Wilkinson Microwave Anisotropy Probe, and the Big Bang Theory. Alfvén's model, Hoyle's steady-state theory, and other comparable approaches have all disappeared from scientific discussions. As a proposed alternative to the Big Bang Theory, they came up with plasma cosmology. Alfvén, a plasma specialist who earned the 1970 Nobel Prize in Physics for his fantastic work on magnetohydrodynamics, proposed the theory underlying plasma cosmology. He suggested using plasma scaling to extrapolate the outcomes of lab tests and plasma physics observations and scale them across several orders of magnitude up to the most prominent detectable objects in the cosmos. According to his theory, the universe is composed equally of matter and antimatter. Cosmic electromagnetic fields are narrow areas of two parallel layers with opposing electrical charges. These are used to define the borders between the matter and the antimatter regions. Radiation would be produced by interacting with these border zones, which would create the plasma. The twin layers are constructed of ambiplasma, which Alfvén coined for a plasma composed of matter and antimatter. Alfvén hypothesized that such an ambiplasma would have a reasonably long lifespan because its constituent particles, as well as antiparticles, would be too hot and low density to quickly destroy one another. To merge clouds of the same kind and create even larger areas of matter and antimatter, the double layers will operate to repel clouds of the opposing type. The Alfvén-Klein model of the universe, also known as the meta-galaxy, was created in 1971 by Swedish theoretical physicist Oskar Klein. Hence, it is dubbed Alfvén-Klein cosmology. Starting from an initial condition of precise symmetry between matter and antimatter, Alfvén-Klein cosmology was suggested to explain the baryon asymmetry in the cosmos. Alfvén and Klein postulated that ambiplasma would spontaneously produce pockets of matter and antimatter that would expand outward when annihilation between matter and antimatter took place in the double layer at the boundary. They concluded that the baryon asymmetry was simply that we happened to reside in one of the pockets where baryons predominated over antibaryons. Alfvén thought that the observable expansion of the cosmos might be explained by annihilations at the boundary, which would cause the pockets or bubbles of matter or antimatter to expand, since they would be simply a local phase of a much more significant history. Due to causality considerations and the denial of other theories such as the Big Bang as a covert form of creationism, Alfvén proposed that the cosmos has always been. Alfvén also proposed the bursting double layer as a potential mechanism for producing cosmic rays, X-ray bursts, and gamma-ray bursts. Because plasma cosmology does not reflect the data of astrophysical phenomena and generally accepted Big Bang model, for this reason, astrophysicists and cosmologists who have reviewed it reject it. According to Jim Peebles, a theoretical cosmologist who attacked Alfvén-Klein cosmology in 1993, there is no way that the findings can be compatible with the isotropy of cosmic microwave background radiation and X-ray backgrounds. Additionally, he demonstrated in his book that Alfvén's theories cannot account for Hubble's law, the number of light elements, or the cosmic microwave background. The fact that matter-antimatter annihilation generates high-energy photons, yet they are not seen in the quantities expected, is another issue with the ambiplasma model. Since the middle of the 1990s, very few publications that support plasma cosmology have been published. Certain occurrences are genuine and not mutually exclusive, such as how the cosmos began. The unsolved puzzle of how the cosmos came into existence will be a topic of discussion for a long time. Do you agree? Share your thoughts in the comments section. We hope you enjoyed watching this video. If yes, we're sure you would like this next video here. Thanks for watching.